This is the Chapter 6 section on application problems regarding quadratics. I'm going to go through a number theory problem, an economics problem, and a handful of physics problems. So let's get started. This first one here is asking you to find two numbers that add to negative 29 and multiply to a positive 78. And so what we're going to do here is we're going to write equations that represent each of those conditions that are being set in the original problem. And if any of you remember linear equations where you have to set up problems and then do some substitution to put them together, we're going to use the same concept, except because there's multiplication involved, we're not going to get that same type of linear substitution. We're going to get a quadratic. So the first thing says two numbers that add to negative 29. So I'm going to use the variables x and y, because they're just variables I'm comfortable with using, and say that when you add them together, it equals negative 29. On the same line of thought, I'm going to say that x times y equals a positive 78. Now, if I want to get this in a quadratic and be able to solve it, I need to eliminate one of my variables, and I'm going to use substitution to do that. So I'm going to solve for y so that I am left with only x's in my equation on the right. So to do that, I subtract x from both sides, and I end up with y equals negative x minus 29. I'm going to take that, substitute it into my original equation for y, so that I get x times the quantity negative x minus 29, all equal to a positive 78. I'm going to go ahead and expand that, distribute out that x, get everything on the same side of the equation, so that now I'm left with something that looks much more like a quadratic. And in fact, because it's all on the one side of the equation, it's in standard form. Once it's in standard form, we can use the technique of the quadratic equation by identifying our a, b, and c terms and just pop it into the equation to go ahead and solve for our values of x. So that's what we're going to do here. Since our coefficient here in front is a negative, the 1 is implied. We know that a is negative 1. Coefficient of the x to the first term is the negative 29. And the coefficient, the constant left by itself out here, negative 78. So let's go ahead and pop this into our quadratic equation. And of course we're solving for x, so x equals negative, or the opposite of that b term, negative 29, plus or minus the square root of b squared, so negative 29 squared, minus 4 times a, which is negative 1, times c, which is negative 78, all of that over 2a, or 2 times negative 1. Not going to go through the steps of solving it here, since the main goal of this lesson is to look at how to set up these equations. So jumping ahead, we're going to, after we solve our quadratic equation, we're going to be left with x equals negative 3, or x equals negative 26. Now, in the context of this problem, we want to make sure that these answers make sense. Now, if we look at x being negative 26 in our equation over here on the left, then negative 26 plus what equals negative 29? Well, negative 3. So it looks like y would actually have to be negative 3 if x was negative 26. And in fact, if you tried using x equals negative 3, then y would have to equal negative 26. So in the context of this problem, it looks like these two solutions here are actually the two numbers that we're looking for. And let's go ahead and just check that in the other equation. If we put in negative 3 for one of our values and multiply that times negative 26, it in fact does come out to a positive 78. So the solutions that we're looking for, the two numbers that add together to negative 29 and multiply to positive 78 are negative 3 and negative 26. The next problem we're going to look at is borrowed from economics. And the basic property that's being talked about here is the idea that as you lower the price for a product, more people are likely to buy it. And obviously in small cases this may not always hold true, but on the macro scale in a large economy, this is something that is regularly the case. So as an example, if I'm selling cookies for $1 a piece, I have been able to predict that 50 students will buy those cookies. However, if I lower the price by 10 cents, so if I only charge 90 cents for a cookie, I'm going to pick up 10 more buyers. So I'm going to go from 50 to 60 students. What price should I charge in order to generate the most revenue? The way that you calculate the revenue in a problem like this is by looking at the price you charge per item and the number of items that you sell. So if I sell 50 cookies to 50 students and I charge $1 each, I'm going to make $50, and so on and so forth. So we're going to use that basic equation to get us started. So revenue is equal to the price times the number of students, or times the number of sales. But then we need to figure out how we're going to define price and how we're going to calculate the number of students. It says in the problem that cookies are $1 each to start out with. So we have that $1 to start out with. And in the same way, it says that I have 50 students to start out with. But it also has conditions for being able to change that. So it says I'm capable of lowering the price in 10-cent increments. So I'm going to use X to represent a single increment that I'm dropping in. So again, we started out with that base constant, and then every increment that I drop it, the price will go down 10 cents. So if I go down one increment, the price is down to 90 cents, and so on. Same thing with students. For every increment that I make, I pick up 10 more students. So I'm going to pay a plus 10x. So if I increment by 1, I'm up to 60 students. Increment by 2, I'm up to 70 students, and so on. Once you get the core components of this problem set up, it's just a matter of substituting in this value for price in this equation and this value for students in this equation. So that you're left with revenue equal to grouping 1 minus 0.1x times 50 plus 10x. Go ahead and expand that, FOIL that out, and you're left with 50 minus 5x plus 10x minus x squared, and that simplifies down to negative x squared plus 5x plus 50. That equation, as we saw in the first one, is in standard form, written with ax squared plus bx plus c. So we can use that to pop it into the quadratic equation. Excuse me on that last part. We could put it in the quadratic equation. However, in this particular problem, it asks, what should I charge to generate the most revenue? So we're looking for a maximum on this graph. And if you remember from the first section, a maximum or minimum can be found at a vertex. So as long as this parabola is pointing downwards, which we can see from the negative term in front of that x squared, that the parabola is facing downwards, we know that it's going to have a maximum. And so to calculate that maximum, we just try to find the vertex. So we go ahead and pop it into the equation here. X equals negative b over 2a. To calculate our x value, use 5 for b and negative 1 for a. And that solves down to 2.5 or 2.5. So that's the x value of our vertex. The question says, what price should I charge? So we pop that 2.5 for x back into our price equation, and we're left with $1 minus 10 cents times 2.5, so minus a quarter, and we're left with 75 cents. So in order to maximize the profit or the revenue for this problem, because we found the max of this equation here, the revenue equation, we found it to be at x equals 2.5, which is a price, corresponds to a price of 75 cents. Now we're going to jump into the physics problems. The basic equation that governs most physics problems as far as the projectile motion or position in motion of an object is to say the height at any given time t, so let's say 3 seconds from now, 5 seconds from now, whatever t happens to equal, the height at that given time is going to be equal to the acceleration times t squared plus the velocity, initial velocity, times t, plus the initial height. This might seem a little bit abstract right now, but as we get into the examples, I'll show you what that means. The acceleration is usually referring to gravity. It's a force that's acting on something that's going to push it downwards. The initial velocity is how fast it was moving from the start. And the initial height is how high above the ground, whatever you're defining the ground to be, it was at the beginning. So let's get into the examples to see exactly what this means. An object was dropped from a 160-foot building 1 second ago. How far above the ground is it now? So let's pretend that this ball here, this red ball, is on top of this 160-foot building, and you drop it. It's falling, it's falling, it's falling, and it falls for 1 second. We want to know how far it traveled in that 1 second. So what we're going to do is we're going to see if we can use this equation up top and fill in the variables that are given in the problem. So h of t is the height above the ground at a given time. That's what the question is asking us to find, so we don't know that yet. T is the number of seconds that have passed, and it says it was dropped from the building 1 second ago, so t is equal to 1 second. The initial velocity, this problem talks nothing about initial velocity. It says it was dropped, which when you drop something, you're not throwing it, you're just releasing it with no initial push in any given direction. So when something is dropped or just let go, it doesn't have an initial velocity. It has an initial velocity of 0. And for the purposes of these problems, we're going to use feet per second, or seconds. And the initial height is how far it was above the ground at the start. If you look here, 160-foot building was 160 feet above the ground at the start. So that's where our initial position was. Once we know this, it's just a matter of plugging it into our equation. So h of t, which we didn't know, so we're going to leave that as it is equal to negative 16, which is the acceleration due to gravity, that's just built into the equation for us, times t squared, which is 1, so times 1 squared, plus 0t, our initial velocity, we said was 0 because it was just released from rest, plus 160, because it was 160 feet above the ground at the start. You go ahead and square the 1, you get negative 16. The 0t term drops out. You have negative 16 plus 160, and that's equal to 144. So the answer to the question is, it was 144 feet above the ground 1 second after being dropped.